In order to integrate in cylindrical coordinates, we need to verify a few things. First, we need to know that a function g of x, y, z is continuous on a region B. In this case, B is a rectangular box described in cylindrical coordinates. We then convert g to polar coordinates, and from there find a function f in cylindrical coordinates. Fubini's theorem in cylindrical coordinates tells us that the triple integral over the region B of g of x, y, z is equal to the triple integral over the region B of f of r theta z times r dr d theta dz. To evaluate the integral of f of r theta z times r dr d theta dz, we use the corresponding bounds defined for r, theta, and z in the region B. Once we have the integral in this form, we can evaluate it just as we would any other iterated integral. Let's try an example of this. We want to evaluate the integral over the region B, and we can tell you from our bounds that B is defined such that r goes from 0 to 3, theta goes from 0 to pi over 2, and z goes from 0 to 2. We'll start by integrating with respect to r. Notice that we actually have two instances of r here, so we can rewrite this as the integral with respect to z from 0 to 2, of the integral with respect to theta from 0 to pi over 2, of the integral with respect to r from 0 to 3, of 3r squared z sine theta. Since each variable is independent of the others, we'll break this up into three integrals so it is a bit simpler to work with. Now we have the integral from 0 to 2 of z dz times the integral from 0 to pi over 2 of sine theta times the integral from 0 to 3 of 3r squared. We can now evaluate each of these integrals individually and multiply the results to get our final answer. Let's go ahead and evaluate each integral individually. The integral of z dz is z squared over 2, and we want to evaluate this from 0 to 2. If we look at our second integral, the integral of sine theta d theta is negative cosine theta. We want to evaluate this portion from 0 to pi over 2. Looking at the third integral, we know that the integral of r squared is going to be r cubed over 3. Since we have a coefficient of 3, the denominator will cancel out and we are just left with r cubed, and we'll evaluate this from 0 to 3. Now we'll evaluate each result to find our final answer. If we evaluate our first result from 0 to 2, we get 2. Evaluating the second result, we get the negative cosine of pi over 2, which is 0, minus the negative cosine of 0, which is 1. This means that we have 0 minus negative 1, which just gives us 1. Finally, we'll evaluate r cubed from 0 to 3. This gives us 27. Now, to get our final answer, we'll multiply all of these together to get 54.